Okay, so let's go here with part 2 on the inverse functions. So using the horizontal line test, or that, algebraic way of doing f of a equals f of b leads to a equals b, that can tell us when we have if we have an inverse. So now the idea is, how do we find an inverse if we have it? So let's start with something easy, and then we'll bump up the difficulty level. So finding inverses. So at this point, we're going to assume one-to-one. So we don't need to do what we were doing in the first part. We're just going to find the inverse. So let's say that f of x was equal to 7x minus 13. And someone said, find the inverse. Now let me assure you that it is one-to-one. It does pass the horizontal line test. So this is just a couple parts. It's like a couple steps that you have to do, and once you go through the steps, it should be pretty straightforward. So the first thing that we're going to do is change f of x to y. So we're going to rewrite this as y equals 7x minus 3. The next thing that we're going to do, so second, is that we are going to flip the x and y. So flip the x and y. So remember that what we're doing here for inverse functions is we're finding the opposite, or the reverse, or the undo. So if we want to go backwards, we're going to flip everything around. So it's going to be x equals 7y minus 13. Then the third thing we'll do is solve for y. So we want the y alone again. So we'll add the 13, so we have x plus 13 equals 7y. And then we're going to divide by the 7. And I'm going to flip this around so it looks like y equals x plus 13 over 7. So we have flipped everything around and solved. And as you can see, it does have the opposite operations. There was a subtraction here, there's an addition here, this was multiplication, now there's division. So when you're doing this, it should contain the same numbers. If you ended up with like x plus 520 over 2, probably did something incredibly wrong. So the same numbers, just in a different format here. Now, this guy is the inverse. So there's the original, this is the inverse. So the fourth thing we have to do is we have to tell people that this guy is the inverse. So we need to use what we call inverse notation. And inverse notation is f to the -1 of x. So I know it seems kind of weird, f to the -1, but when we see that -1, that tells us inverse. So now I can say f inverse of x, that's how that's said, f inverse of x is x plus 13 over 7. And so now if someone was coming into the room, they could see that I've got f of x here and I've got f inverse here, and immediately they know that those two functions are tied together. They are inverses or opposites or reverses, however you want to say it, of each other. Okay? So that's the process, and as I said, we just do the process each time we're given a problem. There's only one little issue that we have sometimes, and that ends up if we have a domain issue. Of course, it always ends up with a domain issue. So I'm just going to erase that so I have enough space to go over here. So this time, let's say that g of x was equal to x plus 8 over x. So trust me again that it is one-to-one. Okay, we can find the inverse here. okay? But the problem is we've got multiple x's and we've got one x in the denominator. So the first thing that we need to do, and it's not going to be written there, is we need to write the domain and say that x cannot equal 0, right? So x cannot equal 0, and that's an important part of the problem. So now if we want to run through the steps, okay, so domain, now we run through the steps. So we change this guy over to y. And this guy is still here, okay? And now I'm going to switch all of the x's and y's. So we're going to say x equals y plus 8 over y. And there's one more that we have to switch. Now, when we flip-flop things, the domain is now going to become the range, and the range is y cannot equal 0. So there is that issue with the domain, which then becomes the range. So that's part of the inverse, okay? It's most definitely part of the inverse. It's very important. Now we need to get y alone, and this one's a little harder than the last one. So we're going to start by getting rid of the fraction. So if we multiply by y on each side, we'll have xy equals y plus 8. And now we can subtract the y to the other side. So we have xy minus y equals 8. And now when you have two y's like this in each term, the only way out here is to factor. So we're going to factor y out to the front, and we'll be left with x minus 1. Okay, so that's your little key there, is that you're going to factor. Okay, so we factor. And then if we divide by the x minus 1, we end up with y equals 8 over x minus 1. Alrighty, so now we've got the y alone. That's what we were doing, solving for y. We've got our new fraction here. And this guy is this guy's inverse. So we're going to name him g inverse of x equals 8 over x minus 1. All right, so this I need to see. So when you're doing a problem, over here we didn't have any issues, right? This was just a nice line, I mean, minus 13 and 7, but a nice line. Over here, though, we most definitely have an issue because of the denominator, and so we definitely need to see that as part of the problem. So again, as always, when the domain becomes an issue, I need to see it. That's really important in this class. If I feel like I'm just repeating myself over and over again about that, I apologize. Okay. So finding inverse. Now the only other thing in this section, or the last thing in this section, would be to check if functions are inverses of each other. So let's say that you had this guy and you have this guy, but you're like, crap, I'm not sure. I don't know if they're inverses. So we're going to check for inverses. So checking inverses, and we do this with composition of functions. So this says if f times f prime of x equals x, which equals f prime of x, f prime of f of x, then we know we have inverse functions. Okay, so it's a composition situation. If we plug one function into the other function, and then we're going to do some math, and what we're hoping that the answer ends up being is x, then we're looking good. But the other thing is we've got to do the composition both ways. So in our case, if we have g of x is x plus 8 over x, and we think we have g prime of x because we worked it out, but we're not 100% sure, so we'll do this. X minus 1, 8 over x minus 1. So what we're going to do is we're going to find g of g inverse of x. So we're going to stick this guy in here, and it's going to look a little bit ugly, okay? So this is an ugly one. So we're going to stick 8 over x minus 1 right there. So we're going to go 8 over x minus 1 plus 8 all over, and then we got to plug it in again, 8 over x minus 1. Ugh, it looks ugly. It's not super, if it works nicely, it should work nicely and it shouldn't be super ugly. So we do have a complex fraction though. So if we're going to start working this out, the first thing we need to do is get a common denominator here. So we're going to need to hit this guy with an x minus 1 and an x minus 1 up here. That makes sense? So let me erase this. Okie dokie. So we now will have 8 plus 8x minus 8 all over x minus 1 all over 8 over x minus 1. Ay, ay, ay. Okay, so we can simplify a little bit here by getting rid of those two guys. Okay, everybody agree? And then, because it's a complex fraction, can we flip and multiply? So can we write this as 8x over x minus 1 times x minus 1 over 8, right? Flip and multiply. But oh my gosh, lo and behold, what happens? Boop, boop, and then also boop, boop, and all that's left is an x. And that's exactly what we wanted to happen. So yeah, we had to do a little fraction work, but you know what? You can do fraction work, but we're not done. Because even though it worked one way, we've got to make sure it works the other way, okay? So you've got to do it both ways. That's part of the like proving it. So now we're going to go the other way. We're going to find g prime of g of x. So we're going to take this guy and we're going to stick it in here. So we're going to have 8 on the top, and on the bottom we're going to put x plus 8 over x minus 1. All right, it doesn't look as ugly as the last one, but on the bottom here, we still do need a common denominator, don't we? So common denominator wise, let's go x over x. That look good to everybody? So we'll have 8 up top, and then x plus 8 minus x all over x. But again, we've got a little canceling we can do, so we can cancel those guys out. And then we're going to flip this bottom fraction and multiply. So we'll have 8, the top, or if you want, you can write it 8 over 1. And then we're going to flip this guy, boop, so it becomes x over 8. And lo and behold, what happens again? Cancel, cancel, and we're left with x. So yes, they are inverses. Okay, so that is the second part of this lecture. So the finding inverses, the flipping the x and y and solving, that's the finding part of it. And then checking for inverses requires these 2 composition problems. But once you've got that done, then you're good to go. All right, so we have looked at inverse functions. All righty, and we're done with what we're gonna do in chapter 5. See you next time.